Welcome to Maths with EJD. I've been treating matrices in the past few classes, and today is the third one where we talk about matrix operations. Well, straight to the point, as you can see, we have operations like addition, subtraction, and scalar multiplication to deal with in this particular lecture. And of course, for you to add or subtract two or more matrices, they must have the same dimensions for addition and subtraction. And then you add and subtract corresponding elements. So matrix addition and subtraction is only possible for matrices with the same dimensions. Okay. Same dimensions are required for addition and subtraction of matrices, and the addition and subtractions are done on corresponding elements. And then, of course, talking about scalar multiplication, we multiply each element of the matrix by a particular scalar quantity. A scalar quantity is just simply maybe a number, an integer, an integer, a fraction, any number like that. You can multiply that with each element of a matrix, and with that you have scalar multiplication. Each element is multiplied by the scalar. Okay, so on the second slide, we see this question, which is going to be the focus of every other thing I do in the rest of this class. So I'm going to be working with these four matrices for the rest of this class. Even there's an exercise at the end, which you can try your hand on. They are still based on these particular matrices. So given matrix A, which is a 2 by 2 matrix, matrix B, a 3 by 2 matrix, matrix C, a 2 by 2 matrix, and matrix D, which is a 3 by 2 matrix. Question, which of the matrices can be added or subtracted? Then do all the possible additions and subtractions. Do all the possible additions and subtractions. Okay, I give you like 5 seconds to think about which of these matrices can be added. Can you add A to B? Can you add A to C? Can you add A to D? Or can you add B to C? Can you add B to D? Think about that. And you can put your responses in the comment section, as you're listening to this. Okay, let's go ahead and deal with these questions. Okay, talking about the solutions now, since matrices A and C are both 2 by 2 matrices, they can be added and subtracted because we need matrices to be of the same dimension for us to be able to add or subtract them. Okay, so you can add A and C. A and C can be added and subtracted because they are both 2 by 2 matrices. On the other hand, matrices B and D can be added and subtracted because they are both 3 by 2 matrices. And of course, since you have established the matrices you can add and subtract, and the second question is it requires us to do all the possible additions and subtractions. Okay, so it means you can add A and C, you can subtract A from C, you can also subtract C from A. Okay, I'm skipping that here, so you can take that as your own assignment. You can do C minus A, which I have not done here. Then you can do D minus B. See, it's really simple because to just be the signs will just be reversed, for in the answers for A minus C and B minus D respectively. Okay, so let's go to A plus C. So this is matrix A with elements 2, 4 in the first row, 3, 6 in the second row. Matrix C, elements -3, -1 in the first row, 4, 5 in the second row. So, and like we've established already, to add two matrices, you add corresponding elements. So it means you add 2 to -3, you add 4 to -1, you add 3 to 4, you add 6 to 5. And that is what you have going on here. So you have 2 plus -3. I intentionally did that to I could easily jump, but I just wanted to do that to make sure it's all clear. So you have 2 plus minus 3, then 4 plus minus 1, then 3 plus 4, and then 6 plus 5. And then that takes us back to the elementary knowledge of arithmetics. This is more like plus times minus, which is minus. So plus and minus will give you minus. Plus and minus will give you minus. So then you have 2 minus 3, and then 4 minus 1. Then 3 plus 4, 6 plus 5 easily. And then 2 minus 3 is minus 1. 4 minus 1 is 3. 3 plus 4 is 7. 6 plus 5 is 11. Okay, so that takes care of addition of A and C. Of course, it is also understood that A plus C, A plus C is the same as C plus A, you know. That is uh the idea of symmetricity. A plus C is equal to C plus A. Okay, so then we go to A minus C. The only difference here is that instead of plus, we have minus here, and then we subtract corresponding elements. So we have 2 minus minus 3 here, 4 minus minus 1 here, 3 minus 4 here, then 6 minus 5, that comes here. And then minus times minus is plus. So you have 2 plus 3, 4 plus 1, 3 minus 4, 6 minus 5. So 2 plus 3 is 5, 4 plus 1 is 5, 3 minus 4 is minus 1, 6 minus 5 is 1, like that. Okay, maybe for the sake of refreshing your memory, you need to remember always that, where can I put that? That minus times minus is plus, minus times plus is minus, then plus times minus is minus, then plus times plus is plus. Now, the summary of that would be if you're multiplying the same signs, minus, minus, plus, plus, the answer is plus. But once the signs are different, minus, plus, plus, minus, you get minus. And that is what we applied, in dealing with all the plus minus situations we had. So then we go ahead to talk about B plus D. So already it's clear that you can add B and D because they are both 3 by 2 matrices. So you have 5, 2, 1, 3, 7, 0, then 4, 5, 1 minus 1, 2 minus 2. So you have 5 plus 4, 2 plus 5, 1 plus 1, 3 plus minus 1, then 7 plus 2, then 0 plus minus 2. This. And then you go ahead to have 5 plus 4, 2 plus 5. So we just deal with the sign, double sign, so to speak. So plus times minus is minus. Plus times minus is minus. So you have 5 plus 4, that's 9. 2 plus 5 is 7. 1 plus 1 is 2. 3 minus 1 is 2. 7 plus 2 is 9. 0 minus 2 is minus 2. Now, in the real situation, you can, if you are in an, if you don't have to go through all these steps, right? You can easily jump from here to here because you just have to add corresponding elements. But of course, one thing I've learned in my years studying mathematics is that, you know, two people can have the same answer, but then one person gets a higher score than the other because of details. So if you jump from, just this part to this part, your answer is correct, right? But you mean somebody who did all the steps may get more marks because it's about the steps you take to get to the answer. Anybody can get the answers, but do you want to show that you really know the steps, especially if you're not racing against time. All right. So that takes us to the last one on this page, B minus D. So we just subtract corresponding terms like we said. So 5 minus, so B is 521,370. Okay, we know that already. D is 4, 5, 1 minus 1, 2 minus 2. Then we are subtracting now. So you have 5 minus 4, 2 minus 5, 1 minus 1, 3 minus minus 1, 7 minus 2, 0 minus minus 2. And then to make sure things are tidy enough, you know, um, so we have 5 minus 4, 2 minus 5, 1 minus 1. Minus times minus like you have up here, minus times minus is plus. So uh my 3 minus minus 1 is 3 plus 1. 7 minus 2, that's okay. 0 minus minus 2 is 0 plus 2. And then you can have 5 minus 4, 1. 2 minus 5 minus 3. 1 minus 1, 0. 3 plus 1, 4. 7 minus 2, 5. And 0 plus 2, 2. So that way, we have done the all the additions and 2 of the subtractions. Of course, the other subtraction will just be, of course, you can already expect that just like A plus C is C plus A, but then you should know that A minus C is equal to the negative of C minus A, or better still, since you already have A minus C, you can, you should be saying that C minus A is the negative of A minus C. That means C minus A is going to be minus 5 plus 1 minus 1, like that. And the same would apply to D minus B. So D minus B would be the negative of B minus D. So D minus B is going to be minus 1, 3, 0, minus 4, minus 5, minus 2. So that goes. And then we move on to scalar multiplication. So in the case of scalar multiplication, we multiply a matrix A by a scalar number K such that we have K times A. So you have matrix A, you have a scalar number K, and then that gives us Ka, which is also a matrix, right? Of the same dimension as matrix A that you started with. So let's look at these examples. Using the previous matrices A, B, C, D, the matrices on the page on two slides before now. So we can look for 3A. If you're looking for 3, it means you're multiplying 3 by the matrix A. And matrix A is 2, 4, 3, 6. So in this case, you multiply each element by 3. So you have 3 times 2, 3 times 4, 3 times 3, 3 times 6. And then you have 6, 12, 9, 18. Then, of course, it doesn't have to be whole number alone. It could also be a fraction like 1 over 4. So here 1 over 4 is the scalar, just like 3 over 4 was the scalar in the previous one. So you have 1 over 4d, which is 1 over 4 times 4, 5, 1 minus 1, 2 minus 2. So you multiply each element by 1 over 4. So you have 1 over 4 times 4, 1 over 4 times 5, 1 over 4 times 1, 1 over 4 times minus 1, 1 over 4 times 2, 1 over 4 times minus 2. So that ends up giving you 1 over 4 times 4 is 1. 1 over 4 times 5 is 5 over 4, or one whole number, 1 over 4, if you like. Then, well, it's better to leave it this way. So 1 over 4 times 1 is 1 over 4. 1 over 4 times minus 1 is minus 1 over 4. 1 over 4 times 2, 2 goes here 1, 2 goes here 2. So you have 1 over 2. The 1 over 4 times minus 2, again, 2 goes here 1, 2 goes here 2. But there's a negative sign there. So you have minus 1 over 2. And that is why you have this. Okay, so with that, we go to the last slide for today. For this particular class. Now, we have an exercise there, so you can try your hands on them. With the given ABCD on the second slide, right? The same ABCD we started with. So find A, half of A minus 3C, then B, minus 5B plus 1 over 4D, and C, 3A plus 2C. And of course, 1 over 3B minus 6D. So I'm choosing to do D so you can have an idea of what you're expected to get. So you have 1 over 3B minus 6D, right? That means 1 over 3 times B, then 6 times D. So 1 over 3 times this, I just went straight now instead of going through all the steps like before. So you have 5 over 3, 2 over 3, 1 over 3. 1 over 3 times 3 is 1. 7 times 1 over 3, that's 7 over 3. 1 over 3 times 0 is 0. And then here you have multiplying everything by 6. You have 6 times 4, 24, 30, 6 minus 6, 12 minus 12. And then we say 5 over 3 minus 24. That's what you have here. 2 over 3 minus 30. That's what you have here. 1 over 3 minus 6. That's what you have here. 1 minus 6. I went straight to say minus is plus. So I just say 1 plus 6. 7 over 3 minus 12 here. Then 0 minus minus 12, that's 0 plus 12. Then if you do all the, fraction, all the subtraction and addition, that's what you end up getting. I'll do, um, 5 over 3, 5 over 3 minus 24 over 1. Of course, the LCM here is 3. So 3 and 3 is 3 times, is 1. 1 times 5 is 5 minus 1 and 3 is 3. 3 times 24 is 72. And then 5 minus 72 is minus 67 over 3. So if you do that for the rest, if you do the same for the rest, you end up getting this matrix. Of course, this can be factorized further, if you like. You can actually bring this you can have something like 1 over 3b minus 6d, which will now be equal to, so you can choose to bring out minus 1 over 3. If you bring out minus 1 over 3, then you have 67 here. Then there you have 88. Next here you have 17. Then here, because you brought out minus 1 over 3, that is going to be minus 21, I believe. Yeah, I think that's minus 21. And then this is 29. And then the last one would be, since you brought out minus 1 over 3, so you can multiply the whole numbers by minus 3. So minus 3 times 7 gives minus 21. The minus 3 times 12 should be minus 36. So if the idea is if you multiply through by minus 1 over 3, you get this same thing. So you can leave it this way, of course, but you can also tidy it up if you choose like that. So if you want to tidy it up this way and you bring out minus 1 over 3, you have 1 over 3b minus 60 is minus 1 over 3 into 67, 88, 17, minus 21, 29, and minus 36. And on that note, we have come to the end of the class. Please try your hands on the exercise so you can be sure you understand all I've been explaining. Feel free to, you can maybe upload your results in the comment section. If I have time, I can check through sometime. Thank you so much for listening. See you in the next one.